Hello and welcome to another video on derivatives. In this video, we are going to discuss about derivatives of logarithmic and exponential functions. So the derivative of natural log of x is given by 1 over x. It's right here, provided that x is positive. Or if there is a composition of natural log of x and another function f of x. So if we have this composition function, then the derivative is f prime of x over f of x. Or it's same as, so if you look over here, the derivative of natural log of something is 1 over whatever that function is. And then using chain rule, the derivative of f of x is f prime of x, and that gives us f prime of x over f of x. So before we move on to examples, let's go ahead and at least prove this formula right here, okay? So here our function is natural log of x. So let's say y equals natural log of x. Now let's go ahead and write the equivalent exponential equation for this one, which is e to the y equals x. Now differentiating this implicitly with respect to x, we'll get e to the y dy over dx equals, so derivative of x is 1. Now if we divide by e to the y on both sides, so we get dy over dx equals 1 over e to the y. And then we know that e to the y is just x, so this equals dy over dx equals 1 over x. So that's why the derivative of natural log of x is 1 over x. Now let's look at some examples. The first example, so we can either use this, so if we have natural log of f of x, we are finding the derivative with respect to x, so that is f prime of x over f of x. Or we can also say it is 1 over f of x times f prime of x, however we call it. So now let's go ahead and differentiate this one. So dy over dx equals, so natural log of a function is 1 over that function, which is 3x squared plus 2x minus 6 times the derivative of this function, which is, we're just using the chain rule here, okay? So derivative of that function is 6x plus 2. Now if we put these two together, we get dy over dx equals 6x plus 2 divided by 3x squared plus 2x minus 6, and that is the final answer. Now let's look at this next example here. Here we have two functions, x and natural log of x. That means we have to use the product rule. So let's go ahead and use the product rule. So the derivative of this function is dy over dx. Now using the product rule, so first function times derivative of second function. So derivative of natural log of x is 1 over x plus second function, which is natural log of x, times derivative of first function. The first function is x, so derivative of x is 1. And then that gives us dy over dx. Now the first one, x times 1 over x, is just 1, plus natural log of x times 1 is just natural log of x. And that is the derivative. Now let's look at another example here. We have the natural log of cosine x. So again, if we use that f prime of x over f of x, or 1 over f of x times f prime of x, however we call it, it's the same thing. So the derivative of this function, dy over dx, equals, so natural log of cosine x means 1 over cosine x, or 1 over f of x, times the derivative of inside function, or cosine x, is negative sine x. Now if we put those two together, then we get dy over dx equals negative sine x over cosine x, and then sine x over cosine x is tangent x. So dy over dx equals negative tangent x, and that is the derivative. Now the next function that we have here, we have to use the quotient rule here because we have a quotient of two functions. So dy over dx. Now if you remember the quotient rule that we use, so this is what I usually say. So I said denominator times derivative of numerator minus numerator times derivative of denominator over denominator squared. So here denominator is x cubed times derivative of numerator. So it is 1 over x cubed times derivative of x cubed, which is 3x squared. So we just did denominator times derivative of numerator minus numerator, which is natural log of x cubed, times the derivative of denominator, which is 3x squared. Everything divided by x cubed. Now let's see what we can do here. Dy over dx equals, so basically we can cancel out this x cubed and that x cubed. So we get 3x squared minus 3x squared natural log of x cubed divided by x cubed. And then if we factor out 3x squared from the numerator, we will get 3x squared times 1 minus natural log of x cubed over x cubed. So this has to be x cubed squared because it's denominator is squared. So this becomes x to the sixth. Now it looks like we can cancel out x squared and 2x's from here, so we get 4 here. So the final answer is dy over dx equals 3 times 1 minus natural log of x cubed divided by x to the fourth. And that is the final answer. That was the those were the examples on finding the derivative involving natural log of x. Now let's look at a general exponential function. Remember, for the natural exponential function e to the x, we already discussed about the derivative of e to the x. Now let's look at a general exponential function, which is b to the x. So how do we find the derivative of that function? So the derivative of the general exponential function b to the x is given by b to the x times natural log of b. So here's the formula. And again, we are going to prove this. So our function here is y equals b to the x. Again, differentiating, before we differentiate, let's go ahead and take the natural log on both sides, okay? So if we take natural log on both sides, so we get natural log of y equals natural log of b to the x, or natural log of y equals, using the law of log, so we can bring that exponent to the front, so we get x natural log of b. Now let's go ahead and differentiate this with respect to x, okay? So implicitly with respect to x, differentiating this equation, we get the derivative of natural log of y with respect to x is 1 over y dy over dx equals, so natural log of b is a constant, so x times natural log of b, so the derivative is just natural log of b. Now if we multiply by y on both sides, so we get dy over dx equals y times natural log of b. And then we know that y is b to the x, so dy over dx equals b to the x natural log of b. So that proves our formula that the derivative of b to the x is b to the x times natural log of b. Now let's look at some examples. So the derivative of b to the x is just b to the x times natural log of b. So here we have 5 to the x. So the derivative f prime of x equals 5 to the x times natural log of 5. Just using that formula. Now let's look at this one. Here we have to use the chain rule. So g prime of t equals, so now we have this coefficient 9, so 9 stays as 9. Now we have b to the x, so the derivative of b to the x is, so we have 2 to the t over 3 times natural log of 2, but it was not just t, we have t over 3, so we need to use the chain rule and we have to find the derivative of t over 3, which is 1/3. Okay, now that gives us g prime of t equals, now we can multiply 9 and the 1/3, which gives us 3, then times 2 to the t over 3 natural log of 2, and then we cannot simplify further, so we'll just leave it here. Now here's a try now problem. I want you to pause the video and try the problem on your own, and then you can resume the video and check your work. So let's go ahead and do it. So we are finding the equation of a tangent line to the graph of the given function at x equals 1. So remember, to find the equation of tangent line, we need a slope and a point. So let's go ahead and find the point, okay? So the point where we are finding the tangent line, or the point of tangency, point of contact, is x value is 1, it's given, so it's 1. Now the y value, to find the y value, we plug the 1 into our function here. So it is 3 times 2 to the 1 is 2, so 3 times 2 is 6, plus 5 times 1 is 5, so 6 plus 5 is 11. So that's the point where we are finding the equation of the tangent line. Now the next thing that we need to find the equation of the tangent line is the slope. So in order to find the slope, we need to find the derivative of that function. So let's go ahead and do that. So dy over dx equals, so 3 times the derivative of 2 to the x is 2 to the x natural log of 2, plus derivative of 5x is 5. Now the slope of the tangent line is given by the derivative of that function at x equals 1, which is 3 times 2 to the 1 natural log of 2 plus 5, which is 6 natural log of 2 plus 5. Let's not put this into the calculator. Let's just leave this as exact. Now the equation of the tangent line is given by, so equation of the tangent line at x equals 1 is y minus y1, which is y minus 11, equals m, which is the slope. So 6 natural log of 2 plus 5 is this slope. So m times x minus x1. Sorry, x1 is 1. We can just leave it here, or we can multiply and then expand this one. So y minus 11 equals, so if we multiply this, so we get 6 natural log of 2 plus 5 times x minus 1 times that one is 6 natural log of 2 minus 5. And then if we add 11 on both sides, so we get y equals 6 natural log of 2 plus 5 is the slope, x, then minus 6 natural log of 2 plus 6, and then we can just leave it here. So let's not put anything in the calculator, let's not round it up, we just want the exact answer, so we'll just leave it right there, okay? So those are the examples involving exponential function. Now the next one we are going to talk about is a little bit more complicated function, where we have to do something called logarithmic differentiation. Okay, so we have to take log on both sides of the equation, or we change the exponential equation into logarithmic equation and then do the differentiation. Okay, so these are a little bit more complicated function. So one thing that we are going to see here obviously is the first example that we are going to see next. Let's go to that example and I'll talk about it. So when we have a function raised to another function, or in more simple way, just to make it more general and then to make you understand this, and I would usually say, if we have variable raised to a variable, okay, if that is the case, we always take log on both sides, and we specifically take the natural log on both sides, okay, just to make that expression a little bit simpler to differentiate. So here our function is f of x equals x to the sine x. So let's, instead of writing f of x, let's write y. So y equals x to the sine x. Now let's take natural log on both sides. That's what we do. So we have variable raised to a variable, or a function raised to a function. So in that case, we are going to take the natural log on both sides. So if we take natural log on both sides, then we get natural log of y equals, now we can use the law of log here. So if we have log x raised to something, then we can bring this exponent down in the front. So sine x natural log of x. Now we are going to do implicit differentiation here. So differentiating this equation implicitly with respect to x, we get, so derivative of natural log of y with respect to x. So we are differentiating with respect to x, okay? So this becomes 1 over y dy over dx equals, now we have to use the product rule here. So the product rule is first function derivative of second plus second function derivative of first. So the first function is sine x. So first function times derivative of second, which is 1 over x, plus second function times derivative of first, which is cosine x. Now we are trying to find dy over dx. So we'll multiply by y on both sides. So we get dy over dx equals y times this whole thing. So sine x times 1 over x is just sine x over x, plus we will write cosine x natural log of x. So let's replace y. Y is our function, so which is x to the sine x. And also let's replace that dy over dx with a prime of x equals y means x to the sine x times we have sine x over x plus cosine x natural log of x. So that is the part A of that question, or the derivative. Now the second part of the question is evaluate that derivative at pi over 2. So a prime of pi over 2 equals, we'll just replace x with pi over 2. So the first one here we have x to the sine x, so that becomes pi over 2 to the sine pi over 2, okay? Then parenthesis sine pi over 2 divided by pi over 2 plus cosine pi over 2 times natural log of pi over 2. So that becomes pi over 2 to the sine pi over 2 is 1 times sine pi over 2 is again 1 divided by pi over 2 plus cosine pi over 2 is 0 times natural log of pi over 2. Now that becomes pi over 2 to the 1 is just pi over 2 times 1 divided by pi over 2 is just the reciprocal of that, which is 2 over pi, plus 0 times anything is 0. So now when we multiply this, we get pi over 2 times 2 pi over 2, just 1. So the value of the derivative at pi over 2 is 1. Now let's look at another example that involves similar type of function. Here again, we have a function raised to a function, or a variable raised to a variable, okay? So now again, we have to use the logarithmic differentiation here. So we'll take log on both sides, or specifically we'll take the natural log. So let's write y equals 1 plus 1 over x to the x, and we are going to take natural log on both sides. And that gives us natural log of y equals, again we'll use the law of log here, and we will bring that exponent to the front. So x natural log of 1 plus 1 over x. And then let's go ahead and differentiate this equation implicitly with respect to x. Okay, so when we differentiate this with respect to x, we get 1 over y times dy over dx equals, now we have to use the product rule here because we have two functions, x and natural log of 1 plus 1 over x. So the first function, derivative of second function, so derivative of natural log of 1 plus 1 over x is 1 over 1 plus 1 over x times the derivative of 1 plus 1 over x is negative 1 over x squared. So that's the first function, derivative of second, plus second function, which is natural log of 1 plus 1 over x, times the derivative of first function is just 1. Now, if we multiply by y on both sides, so we get dy over dx equals y times. Now we can simplify here a little bit. So we have this x and then x squared, so they cancel with each other. So, and then we have, so if we multiply here, so 1 times negative 1 is negative 1 in the numerator. Now, if we multiply this denominator with x, okay, we have x here, so x times 1 is x plus x times 1 over x is just 1, and then plus natural log of 1 plus 1 over x. That's what we have. So now let's write f prime of x equals, now y is 1 plus 1 over x to the x times natural log of 1 plus 1 over x minus, let's write that as the second term. And then that is the derivative of the given function. Now we looked at the natural log, we looked at the general exponential function, and then we looked at some more complicated function where we have to take log. Now let's look at what is the derivative of general log. Okay, not just the natural log, but the general log. So the derivative of general log logarithmic function is right here. So if we have log base a of x, then the derivative is 1 over x times natural log of a. Okay, or if we have a composition function, log base a of f of x, then it is 1 over f of x natural log of a times derivative of f of x, which is f prime x, and that gives us this one. So before using this one, let's go ahead and at least prove this formula right here. Okay, so our function is y equals log base a of x. Now, if we change this to an equivalent exponential function, that becomes a to the y equals x. And then now if we do the implicit differentiation of this equation with respect to x, so the derivative of a to the y is a to the y times natural log of a, and then we have to find the derivative of y, which is dy over dx equals derivative of x is 1. Now we want dy over dx, so if we divide by this quantity on both sides, so a to the y natural log of a to the y natural log of a, then we get dy over dx equals 1 over a to the y natural log of a. Now we know that a to the y is x, so that becomes dy over dx equals 1 over x times natural log of a. And that's what we have right here. So that's how we prove that formula. Now let's go ahead and use this. So the first function that we have is log base 3 of 5 minus x to the 4th. Now the derivative of log base a of x is 1 over x natural log of a. And then if we have any other function here, we have to do the chain rule. So that's what we are going to do here. So we get f prime of x equals, so 1 over x, but we have a function here. So 1 over 5 minus x to the 4th times natural log of 3, and then times the derivative of this function, which is negative 4x cubed. Now if we put these two together, then we get f prime of x equals negative 4x cubed divided by pi minus x to the 4th times natural log of 3. And that's it. Sorry, this is cubed. So let's go ahead and look at the next example that we have here. Here we have two functions, x and log of x over x plus 3. So we have to use the product rule here. So the derivative of this function is f prime of x equals the first function derivative of second. So derivative of this function is 1 over x plus 3 times natural log of 10, because the base of this log is 10. So natural log of 10 times, we need to find the derivative of this inside function, which is a quotient. So we have to use the quotient rule here. So denominator times derivative of numerator minus numerator times derivative of denominator divided by denominator squared times, plus, so we did first function derivative of second plus second function, which is log x over x plus 3 times derivative of first function is just 1. So now this gives us f prime of x equals, so let's go ahead and simplify this. So this is 1 over x plus 3, so that becomes x times x plus 3 over x. And then we have natural log of 10, okay? And then we have times, here we have x plus 3 times 1 minus x is just 3 divided by x plus 3 squared plus log of x over x plus 3. Now we can simplify this. So we can cancel out this x and this x. We can cancel out x plus 3 with 1 of this x plus 3. So we get f prime of x equals 3 over x plus 3 times natural log of 10 plus log x over x plus 3. And then we can just leave it right here. So that is the derivative. Now let's look at one example where we have combination of a couple of things here. We have to use quotient rule, we have to use chain rule, we have to use logarithmic differentiation. So we're going to do a lot of things here, okay? So before we start, let me write this one as, so square root of that function is same as writing 2x cubed plus 3 to the 1/2 divided by x cubed minus x cubed minus 4 cubed, okay? So now we have y equals that function. So if we take natural log on both sides, so this is what we get. So natural log of y equals natural log of this function, which is 2x cubed plus 3 to the 1/2 divided by x cubed minus 4 cubed. Now, let's simplify this using the loss of log. So we have natural log of a quantity divided by another quantity. So if you have natural log of m over n using the rule of log or the loss of log, the quotient law, we can write natural log of m minus natural log of n. So let's do that. Natural log of m means the numerator, 2x cubed plus 3 to the 1/2 minus natural log of the denominator, which is x cubed minus 4 cubed. Again, using the rule of log, what we can do here is we can bring that exponent to the front, and we can bring this exponent to the front. So that becomes natural log of y equals 1/2 natural log of 2x cubed plus 3 minus 3 natural log of x cubed minus 4. Now let's go and do the find the derivative of this function. So we are going to differentiate implicitly this equation, okay, with respect to x. So when we differentiate with respect to x, we get 1 over y dy over dx equals 1/2. So derivative of this function is 1 over 2x cubed plus 3 times the derivative of that function, which is 6x squared, minus 3 times, so derivative of this function is 1 over x cubed minus 4 times derivative of that function, which is 3x squared. Now let's do a couple of things. Let's multiply by y on both sides. So on the left hand side, we just have dy over dx equals y times. Let's go ahead and simplify this. So we have 1/2 here. So 1/2 times 6x squared is just 3x squared divided by 2x cubed plus 3 minus, now 3 times 3x squared is 9x squared over x cubed minus 4. Okay, now this implies dy over dx. Now y is this function here, so we can write that as 2x cubed plus 3 to the 1/2 divided by x cubed minus 4 to the third. And then here, let's go ahead and do this fraction. So this is how I combine this fraction. Okay, you can make common denominator, but we can just do this multiplication, that multiplication, and the multiplication of the bottom. So if we do that, so when we multiply 3x squared times x cubed minus 4, we get 3x to the fifth minus 12x squared. And then when we multiply 9x squared into this one, we get minus 18x to the fifth minus 27x squared divided by 2x cubed plus 3 times x cubed minus 4. Now let's write this one up here. Now this equals, so this one equals, so now we can do a couple of things here. We have 2x cubed plus 3 to the 1/2, 2x cubed plus 3 here, which power is 1. So when we combine that, we are going to get square root of, so let me write that here. Okay, so let me write that next. Before that, let's combine this one. X cubed minus 4 to the third times x cubed minus 4 is x cubed minus 4 to the fourth. Okay, and then when we combine these two, so when we combine this with this one, so sorry, with this one, now this is on the top, this is on the bottom, so it's 1 minus 1/2, so that gives us 2x cubed plus 3 to the 1/2. And in the numerator, we have 3x to the fifth minus 18x to the fifth, which is minus 15x to the fifth. And then we have negative 12x squared minus 27x squared, which gives us negative 39x squared. So the final answer, we can write this one as negative 15x to the fifth minus 39x squared divided by x cubed minus 4 to the fourth, and then square root of 2x cubed plus 3. And that is the final answer. So this is a little bit complicated problem because we have a lot of rules that we need to use here along with the logarithmic differentiation. We'll just stop here for this video. In the next video, we'll talk about the derivative of inverse trigonometric functions.